Okay, hello everyone. I'm audible. Okay. Good afternoon to all. Good afternoon. Just 1 minute. Hello, now audible. Okay. Okay, so let's start the session. Yesterday we had discussed this topic. Okay, concept of unit number 6, planar and non-planar graph. Okay, and this is the first topic of unit number 6. These are the various topics that we'll learn in this unit. Okay, unit number 6. And it is all the topic are applications part of the graph theory, clear, where it is required, okay, as a special case, as a planar and non-planar. Then after embedding two well-known non-planar graph that is known as a Kuratowskis first and second graph, Euler formula to verify the given graph is a planar or not, okay, and then after graph coloring and dual graph, okay. These all are the important concepts in real life as well as in engineering field. So the definitions we had discussed in the last lecture, okay, means yesterday's lecture. So what is meaning of planar graph? Okay, how we can define it, and if we have any graph is given, how we can check given graph is a planar or not? Okay, so what is the definition? Okay, one of the graph is given that which definitely involve the some vertex and edges. Okay, so G is equal to VE, where V is a vertex set, E is a edge set. Okay, and is said to be a planar if it can be drawn. Okay, it can be drawn on a plane so that no two any edge intersect. Okay, means आपको उसको draw करना है. You have to redraw it. If it is given, then you have to redraw it to draw this graph without cross over the edge. If it can be drawn to draw such graph on a plane without intersecting the two edge, okay, at the non-vertex place, then it is called the planar graph. Okay, two graph is given. In this first, there is no any required modification. Okay, in this first graph, there is no any required modification. That clear? All the edge, okay, are connected. Clear? That is connected graph that, and no two any edge are intersect. कोई भी edge intersect नहीं हो रही. ठीक है? No any two edge cross at any non-vertex place. Clear? So that is a planar graph. There is no any required modification. So directly you can say this graph is a planar. Okay. Directly you can say this graph is a planar. Okay. For example, already we discussed. Let's try. Four vertex with four edge. No two any edge are intersect that. So what is the answer for this one? It is a planar graph. Okay. No any edge are cross. What is meaning of cross? If you consider any two edge, okay, and if I consider this, draw this graph in such way. So now it is a intersection of these two edge. Okay. At which place? At non-vertex place. यहाँ पे कोई भी vertex नहीं. There is no vertex at the crossing place. Clear? जहाँ पे वो दोनों cross हो रहे हैं. वहाँ पे कोई भी vertex नहीं. There is no any vertex are there. Only four vertex are given. So this point, okay, is called the non-vertex place. Okay, this is called non-vertex point. Clear? So now this is called intersection between the two edge. Clear? And that is a non-planar situation. If I consider one vertex to that place, Clear? Now it is a 5 vertex with how many edges? 5 vertex edges. Clear? Because that is edge 1. Okay. Now be a vertex. That is vertex with this 4 boundary. There is no any intersection between any two edges. Clear? No any intersection between any two edges. Clear? Now with this 4 edges graph, if I add one more edges, still the graph is a planar. But if I add this one more edges, clear? Now it is a K4 graph. So now the situations become non-planar. Clear? It is a non-planar situation. But we can modify this graph. ठीक है, आप इसको ग्राफ को modify कर सकते हो such that we can remove these intersections which is mentioned in this graph. You can remove this intersection. Okay, you can remove this cross between these two edges as per the given graph. Okay, redraw this graph, consider this inside edge as it is here, one of the edge, and now delete this edge. Okay, and redraw from the outside the graph. Okay, with the same end point. Okay, now these both graph are isomorphic. Clear? They are essentially same. So in place of the first one, you can use the second one without crossover between two edges. So now this answer is a planar. Clear? So it can be drawn. आप उसको draw करना है, ठीक है? आपको उसको draw करना है such that no two any edge are intersect. If it is possible to make such graph without crossover the edge, then it will be the planar. ठीक है? Now third case, in this graph, it is not possible to make this graph without crossover. Okay, means we cannot draw this graph without crossover the edge in any way. That you already checked in the last lecture. Okay, is it clear? We need to repeat it. Okay, this graph will be the non-planar. अगर आप modify करोगे, ठीक है, if you recreate this graph again, then it will be the non-planar case. We cannot draw this graph without cross of the two edges. ठीक है? So at last your answer will be the non-planar. ठीक है, तब आपका आंसर होगा नॉन प्लानर. इफ इट इज नॉट पॉसिबल टू मेक दिस ग्राफ प्लान, ठीक है, देन इट विल बी द नॉन प्लानर केस. If it is directly the planar situation is that no two edges are intersect, then it will be the planar. Okay, your direct answer is a planar. If there is a cross mentioned to the graph, and if it is possible to draw this graph without crossover, then first try it. Okay, and your answer will be the planar. And now third case, here it is not possible to make this graph planar. ठीक है, so your answer will be the non-planar case. ठीक है, तो अगर कोई ग्राफ में क्रॉस है between any two edges, तो पहले आपको उसको प्लेनर में कन्वर्ट करना. ठीक है, you have to try to make the graph is a planar, and at last if it is not possible to make the graph planar, then your answer will be the a given graph is a non-planar graph. Okay, so these definitions we had discussed in the last lecture, and the procedure to make non-planar to the planar, this procedure is called the embedding. Okay, embedding to the graph means a given graph is a non-planar that, and you have to apply the embedding to make is planar. Embedding means you have to modify this graph. ठीक है, उसको modify करना है ऐसे कि we can remove this cross between the two edges. ठीक है, that we do it here. Here that is in K4. That is shape of the K4. Now that is non-planar situation here, and we apply the embedding to this graph to make as a planar. So this procedure to make non-planar to the planar is called the embedding. Okay, that procedure is called the embedding. So apply the embedding to the following graph. So what is meaning of that? कि जो भी ग्राफ वहां पे है उसको आपको प्लेनर में कन्वर्ट करना. ठीक है, apply the embedding to the given graph, the following graph. So to make this given graph as a planar form. ठीक है, if it is possible. So if it is possible, then it will be the planar. If it is not possible, then it a non-planar graph. Okay, it is not possible in any way, then it will be the non-planar graph. Okay, so this part we had discussed in the last lecture. That is one of the example is that in the first case there is a non-planar situation, but we can modify this graph. आप उसको modify कर सकते हो, ठीक है, as a planar situation. ठीक है, so second graph, similar number of vertex, similar number of edges, but the first situation is a non-planar, and the second situation is a planar. Okay, so modifications to the graph, okay, to make non-planar to the planar, that called embedding. Okay, this process is called the embedding to this graph. Okay, we just remove the one of the cross, delete these edges, and recreate it. Okay, to the outside of the graph. Okay, to the boundary of the graph, to the inside of the graph, so that look like now planar form. So it is the planar graph. Okay. So up to this, we had discussed in the last lecture. Clear? Means in the yesterday's lecture. Now next is the application. What is the require of planar graph situation in real life? Okay. What is the useful? Where it is required? Okay. Why we learn this topic? And what is importance in real life? Clear? So here I find some few applications. There are also some more applications will be there. Here you can also find out this all the application. But I just find out one of the real life applications. Clear? In day-to-day life where it is required. Clear? In our daily life कहाँ पे वो use होता है, ठीक है? In which case we can feel that this planar graph condition is required here. Clear? So here one of the real life application is that connecting the utilities. Clear? In application of planar graph, sometimes it is really important to able to draw the graph without crossing the edge. Clear? Sometimes it is required that so to connect this network without crossing the connectivity. Clear? Without crossing the any two edge connectivity there. Sometimes it is very required that. In which case, the first one is here connecting the utilities. What is meaning of utilities? As the electricity, water network, then after natural gas, so to apply the electricity to any of the building, okay, any of the houses, then sometime it is required there is no any intersection between any two wire. Okay, so therefore we consider the junction at this floor of this okay, any building and so on. Clear? So what is meaning of junction? What is importance of junction? We can remove the crossover between the two wire. Clear? That is importance of that one. And that is due to the planar graph concept. Clear? So it is means of electricity network, then after gas pipeline, water pipeline. Sometimes you have to also consider not to any utilities intersect at any place. Okay. For example, water pipeline and gas pipeline. Okay, water pipeline and electricity wire and gas pipeline and so on. So you have to apply such all this network, okay, such a way that not to any connecting utilities should be intersect, means should be cross. Clear? At any way. So that is one of the application here, and here one of its example is that that is also one of the famous problem. Okay, and you can also feel as a real life concept. Okay, that is real life concept we have. So there are three houses. Okay, and we have to apply the three utility to all the three houses. Which three utility? This first one, that is a gas pipeline. Okay, means gas pipeline here. That is a water pipeline. Okay, and water connection. That is one of the main point of the water, and you have to apply the three pipeline to this all the three houses. Okay, and that is electricity. What is the problem here? Consider the problem of joining three houses. These are the three houses A, B, and C. To each of the three separate utilities. Okay, तीनों को separate utility आपको apply करनी है, ठीक है? Means three gas line to the three houses, three water pipeline, and three electricity network. ठीक है? As shown in the figure 1, is it possible to join? Is it possible to join these houses and the utilities so that now this connections cross? Is it possible to apply this all the connectivity to the three houses such that none of the three utilities, okay, none of any two utilities crossed? Okay? And what is importance of this one? It will be safer. Okay, sometimes it will be safer and easier to install to develop such network such a way that not to any network crossed at any place. Clear? So therefore we develop such network such a way that okay to the any houses, to the any building and so on, not to any utilities crossed at any place. Okay, it will be safer in for future as well as it easy to install. Okay, to the any building, otherwise any of the network. Okay, so now is it possible here? You have three houses, okay, A, B, and C, and you have three network, three utilities you have, तो जिसको आपको तीनों houses को connect करना है, ठीक है? As a three gas pipeline, three water, and three electricity wire. So to apply this all the utilities such a way that you have to remove connect to the three houses, not to any utility intersect at any place. Is it possible? How we can check it? Okay, is it possible or not? You just consider any of the diagram, clear? You just remove this cross. That is a situation here, okay? इस तरह से possible है, but it intersect. Okay? That is one solution here, but it is intersect here. Now you have to connect this all the utility. Okay, we modified this graph. Okay, we recreate this situation again without crossing. Okay, without cross at any place. So you can check by this way. Consider these are the three houses A, B, and C, and these are the three utilities. Okay, that is 1, 2, and 3. Okay, these are the three utilities we have. And now let's apply the gas pipeline to all the three houses. Okay, and when we apply only one connection, okay, so there will be no any cross. We just apply the gas pipeline. Okay? That is the first utility. So there is no any cross at any case. Okay, तीन line आपको apply करनी है separately, and there is no any intersection now. Clear? Now second utility, that is water pipeline. ठीक है, कहीं पे आपको intersect नहीं करना. ठीक है, you have to verify that कि कहीं पे भी कोई cross नहीं बनना चाहिए between any two utilities. So that is second, and that is the third. Clear? Now apply second one. Okay. Let's consider this edge. Let's delete this connection here. So we can easily connect the 2 to the B and second utility to the third house. Okay? And let's consider this connection from the outside the boundary. Is it visible? Okay. There are three houses from the first one. Three connections from this first one. That is a 1, that is a 2, and that I consider third one. Why I remove it? Because we can easily connect 2 to the B now, okay, without cross. There is no any intersection till now between any two connectivity. And 2 to the C. Which connection is remaining? 2 to the A. Okay, there is no any pipeline between 2 to the A. If I connect it, okay, if we connect it via this direction, so it will be crossed with this edge. Okay, if I connect outside the boundary, okay, outside this floor, then it will be connect at that place. Okay, if I consider this direction, it also will cross at that place. Okay, so in any case, it is not possible to apply all the three utilities, okay, without cross over the edge. Okay, without cross over the edge. Clear? So that is one application that by using the embedding concept. Okay, that is embedding. We are using the embedding right now. This is one graph here with 6 vertex. कितना vertex है इसमें? 6 vertex, 3 for the houses and 3 for this utility. And these are the network between these 6 vertex. So is it possible to make this graph without cross over the edge or not? Okay, we convert the situations to one of the graph. This is our graph here. Okay, ये एक real life situation है. That is one network here. 3 houses with 3 utilities. Junction. Okay, and we convert this situation to one of the graph. And now you can check it easily. You can verify easily that is it possible or not. And if it is possible, how we can apply this network? Okay, if it is possible, अगर possible है, तो how we can apply this network? It's which directions we have to consider to connect it? Okay, you will get some ideas. Is it possible or not? Okay, if I remove one of the houses, okay, let's take only 2 houses. एक को मैं delete कर दूँ. Okay, now you have the 2 houses with 3 utilities. Now it will be possible. ठीक है, 2 houses के लिए possible होगा without cross over the edge. How it will be possible? Let's check. Let's recreate it. 3 utilities with 2 is A and B. Okay, second utility I apply to the both one, okay, and one utility I apply to the A, and third utility I apply to the B. Okay, still one connection is remaining. Which connection? 1 to the B. Okay, 1 to the B, that is remaining. So I will connect via the upper of the graph, and then after B 1 to the 3 remaining. Sorry, A to the 3 remaining. Okay, so I connect from below directions, and then I connect it. Okay, so that is now. Now you can see that all the 3 utilities are applied to the both houses. ठीक है. These are the two gas pipeline A to the B. These are the two water pipeline A to the B, and these are the two electricity wire network A to the B. And no any edge are intersect at any place. Okay, no any two edge are intersect at any place. Means no any two utilities are intersect. Okay, so you can verify that, you can check that is it possible or not. Okay, is it possible or not? If it is not possible, you have to modify this structure and so on. Okay, you have to modify this place and so on. So from the text, connecting the utility, electricity, water, natural gas to houses, if we can keep from crossing those lines, it will be safer. Okay, safer and easy to install. It is easy to install now comparison to this one. Clear? It is easy to install now comparison to this. Clear? So that is one of the application. Clear? And second application is that connecting the component on circuit board. Okay, you have to develop any of the circuit that of any of the chip, any of the mobile phone, otherwise any of the device and so on. आप कोई circuit develop कर रहे हो, ठीक है? Then it is also required the concept of planar graph that, okay, for connecting the component on circuit board. So here one of the circuit is mentioned that, okay, that is arbitrary circuit. Okay, ये कोई device की circuit नहीं, that is arbitrary connection, I consider it here. And this one arbitrary circuit, ठीक है? It is a cross here. It is a cross between two wire, okay, two network. Clear? That is 1 to the 4 and 2 to the 3 are cross at that place. ठीक है? Now you have to recreate this circuit. इसको आपको recreate करना है, ठीक है, modify करना है such that not to any wire network crossed at any place. ठीक है? So we have to apply the embedding case there. ठीक है? We have to apply the embedding procedure is there to recreate this graph. So all the connections should be as it is there. Okay? No any network should be added. We are just consider same network. Okay? Same junction and same network. And based on that, we can modify this graph such that now this graph is without crossover the edge. Okay, all the connection are as it is that. Okay, we have the connection between 1 to the 4. Okay, there is a wire between 1 to the 4. So here it is also in between 1 to the 4. Okay, there is a edge between 2 to the 3. So it is also given between 2 to the 3. Okay, via this direction. It is a between 2 to the 3 here. Okay, and 1 to the 3 to the 4. Clear? That all are mentioned as per. That is it is given by this direction. One. Clear? It is one in this way. Okay? So now it is modified circuit without crossover there. What is the importance of this one? Okay, why it is required here? That is mentioned in this. The connections on the circuit board cannot cross. If we can connect them without resorting, okay, resorting to another layer of the traces, it will be cheaper to produce. Okay, it will be cheaper to the produce. And here is one of the another example is that ये आपने कहीं पे देखा होगा, ठीक है? That is one of the circuit design. ठीक है? आप कहीं पे भी image भी देख सकते हो, ठीक है? और real life chip of any device and so on. ठीक है? So now see this picture. Is there any cross between any two connection? Okay, these are the main chip. That is Intel. Let us take Intel Core i5, Core i6, and so on. Okay, and these are the connections to this chip. And you can see that not to any connection has intersected any place. Clear? So now we can easily maintain this connection. Okay, we can easily find the route between these locations to this location. Okay, between this place to this place. We can easily check that which two are connected. What is the root of this one? And after that, we can easily identify our problem. Okay, we can easily replace the problematic wire network. If it is mentioned by this way, if it is mixer, okay, it is a cross at any place. Okay, all the edges are network are crossing. So in that it is not easily we can maintain that. Clear? So that is concept of planar graph. Okay, that is concept of planar graph. You can consider any of the chip. Okay, कोई भी device की आप chip ले सकते हो. You just find out its image. Okay, from the Google. and then after observe this chip, okay, chip design, it always will be in planar form. There is no any two edge will be intersected any. Okay, so these are the real life case. Okay, real life example. Clear? That is used in electric engineering and any of the chip. Clear? Any of the circuit board. Its planar graph theory is very useful. Okay. And third one, that is in subway system. Okay, subway road. What is means of that? If the subway lines means a network between two places, okay, needs to cross, and there is needs idea of the planar graph. Needs idea of the planar graph. How we can develop this new network, okay, new road network between two places and so on. And you can see this picture here. It is one of the road network of the one of the city of China. Okay, you just see this picture. There are three road. Okay, they are all. That is a base. Here, ये जो है base है. And that is another one. And this is overlap to this one. There are three parallel road. Here, three road are overlap. That is a base. That is second one, and that is the third one. Clear? That is this base. It is visible or not? Okay. This is a base. ये base है. ठीक है? Ground. And this overlap to this one, and this overlap to this one. Okay? So there are three network. Okay, they develop that to maintain the traffic and so on. So here it is also required the planar graph concept that to maintain that to create this type of design and so on. How we can consider this type of directions. Clear? To maintain the traffic as well as crossover between the two connections. Okay? So therefore they are using this type of concept. Okay? That is one of the loop here. Okay? That is one of the loop concept is that to maintain this design, okay, to remove this crossover, they are considered this type of design. Okay? And one of the example is also available near to Sanand. Okay, it is Sanand Chokdi. If you see this map of the Sanand Chokdi, okay, near Ahmedabad, that is also one of the concept of planar graph. There is no any cross between the. I think there is 8 road that connect at the circle. Okay, so that is also one concept of planar graph. There is also create one of the loop system there to maintain the traffic and remove this crossover. Okay, so that is also required the concept of planar graph. Okay, in subway system. So first and third, that is a real life situation, real life concept. Okay, second one, that is one of the engineering problem there in the circuit board. Clear? That's required the mathematics. Clear? That's required the mathematics. Without mathematics, engineering cannot be defined. Clear? Base is a mathematics. If you know the mathematics, then you are the good engineer. Clear? If you don't know the mathematics, then first you have to try to learn. Then after you can understand the concept of engineering. Clear? That is a base. Engineering का base क्या है? That's maths. ठीक, कोई भी branch आप ले लो, ठीक है? कोई भी branch, mechanical है, civil है, computer IT, then after electrical. ठीक है? Electric engineering depends on the Fourier series, Fourier transpose. पूरा जो communication network है, that depends on the Fourier series and Fourier transpose. Okay? Lots of applications we have to the real life as well as in engineering. Okay? That's required the mathematics concept. So is there any doubt up to this topic to anyone? Is there any confusion? Okay. So let's start the next topic. Two well-known graph, which graph is known as a non-planar graph. Okay. That derived by Kuratowskis, one of the mathematician. Okay. We first verify that these two graphs are non-planar graph. Okay. One of the graph is a K5 and second is a K33. So why consider only K5 and K33? Why it is not a K6? Why it is not a K9? Why it is not K35 and so on? Okay. So there is one reason for that. Why consider K5 only? Okay. Why it is considered K33 only? So up to the K4. Okay. K1 is only one vertex. K2 has a two vertex with one edge. And now shape of the K3 and K4. What is shape of the K3 and K4? Yeah, that is the shape of K3. and that is shape of the K4. See, our K3 is usually a planar graph. There is no any edge or intersect. Okay, this first is the K3 graph, complete graph with 3 vertex. Okay, so second graph is that is a K4. Now it is look like non-planar, but we can easily embed it. Okay, embedding is possible to the K4, and we can easily make the situations as a planar form. Okay, that is now planar of the K4. But in K5, is it not possible? Okay, in K5 it is not possible. We'll also prove it why it is not possible. So this graph is the minimum number of vertex and edge. This graph is a minimum number of vertex. How many vertex to the K5? 5 vertex. And how many edges to the K5? 5 plus 5, 10 edges. Okay, so it has a minimum number of vertex and edges, minimum number of vertex and edges in a complete graph, which is a non-planar graph. Okay, we'll also prove it why it is non-planar. We'll also apply the embedding procedure that in the next example, why it is non-planar. Okay, so here you just consider one of the result here. Okay, this graph has a minimum number of vertex, 5 vertex. Okay, with minimum number of edges, 10 edges, which is a non-planar graph. Okay, and after K5, K6, K7, K9, अगर K5 non-planar है, तो we cannot embed the K6 as a planar form. ठीक है, तो K7, K8, K9, K11, all the graph will be the non-planar graph. ठीक है, after K5, okay, that is minimum number of vertex and minimum number of edges. It is non-planar. ठीक है, so therefore you consider first K5 as a non-planar. That is Kuratowskis first graph, K5. Okay, now second graph, that is a K33. That is a graph of K33. Okay, so here why consider K33 only? Why it is not K23? Okay, K31, K13, and so on. So this graph has a 6 vertex and how many edges? 9 edges. Okay, 3 into 3, 9 edges there. 6 vertex with 9 edges. So it is a minimum number of vertex, 6 vertex, and minimum number of edges, 9 edges in complete bipartite graph, which is a non-planar graph. Okay, it is minimum 1, minimum number of vertex 6, and minimum number of edges 9 in complete bipartite graph. That is bipartite graph, which is a non-planar. Okay, so why it is considered K33? Because it is possible in K23 graph. Okay, we can easily embed K23 graph. That is a 5 vertex with 6 edges. Okay, so let's draw the K23, and then after let's embed it. Okay, this shape of K23, 2 vertex in one side, 3 vertex other side. इसको आप easily embed कर सकते हो. ठीक है, how we can embed it? 2 vertex and 3 vertex opposite side. That is a 2 connection. Now consider this connection from this side and this one from upper side. Okay, now they both are isomorphic. Okay, these both are isomorphic, that is with cross and that is without cross. Okay, so it is easily embedded in the K23 graph, okay, K32 graph, or K31, K51. It is easily possible to make a planar form, but here it is not possible in K33. Okay, it is not possible in K33 graph, which is a minimum number of vertex, 6 vertex, minimum number of edges, 9 edges in complete bipartite graph. Okay, which is non-planar, which is a non-planar graph. Okay, in the first graph, we have the 5 vertex, 10 edges. Here it is a 6 vertex with 9 edges. 6 vertex with 9 edges. Okay, this is minimum one. इसका जो maximum है, that always a non-planar form. ठीक है, 6 vertex, 7 vertex, 8 vertex, 9 vertex, that always a non-planar form. Okay, so let's prove the first one. Why K5 is a non-planar graph. Okay, why we cannot embed the K5 as a planar form. Okay, so there is one first theorem of this unit. Prove that the complete graph with 5 vertex. Prove that complete graph with 5 vertex is a non-planar graph. Okay, means prove that K5 is a non-planar. Okay, K5 is a non-planar. Which type of shape we have? Just check this shape again. This is shape we have of K5. इसको आपको इम्बेड करना है, ठीक है, इसको आपको मॉडिफाई करना है सच दैट नॉट टू एनी एज शुड बी इंटरसेक्ट. कोई भी दो एज इंटरसेक्ट नहीं होनी चाहिए. टू रिक्रिएट दिस ग्राफ, इसको आपको रिक्रिएट करना है, ठीक है. जो भी क्रॉस कहीं पे बन रहा है उसको आपको रिमूव करके फिर से नया ग्राफ बनाना है, ठीक है. एंड एट लास्ट वी गेट वन कंक्लूजन, it will be not possible. Okay, so that is our statement and let's prove it. 5 vertex with 10 edge, ठीक है. 5 vertex with 10 edge, 5 from the boundary and 5 are the inside, ठीक है. इसको आपको रीडिजाइन करना है, ठीक है, रीड्रॉ करना है such that no two any edge should be intersect, ठीक है. so how we can create a K5, K5 कैसे बनता है, ठीक है. तो इस आपको एक्सप्लेन करना है, ठीक है, हाउ वी कैन ड्रॉ द K5. K5 आप कैसे ड्रॉ करोगे, ठीक है. तो फर्स्ट यू शुड हैव द 5 वर्टेक्स. ओके, K5 बनाने के लिए आपके पास 5 वर्टेक्स होने चाहिए. क्लियर? सो दैट आई एक्सप्लेन इट हियर. लेट्स टेक अ 5 वर्टेक्स. 5 vertex in a complete graph be named as a V1, V2, V3, V4, V5. That is arbitrary name. आप वहां पे ABCD भी लिख सकते हो, ठीक है. Consider 5 vertex and consider as name V1, V2, V3, V4, V5. अब सेकंड केस में कंप्लीट ग्राफ की डेफिनेशन एक्सप्लेन की है. तो व्हाट इज मीनिंग ऑफ कंप्लीट ग्राफ, ठीक है. तो कंप्लीट ग्राफ हमेशा क्या होता है, दैट इज सिंपल ग्राफ. ओके, बिकॉज इन कंप्लीट ग्राफ नो एनी लूप, नो एनी पैरेलल एजेस विल बी देयर. ओके, सो इट इज ऑलवेज सिंपल ग्राफ देयर. एंड व्हाट इज अनदर कंडीशन, in which every vertex is joined to every other vertex by means of an edge. Means each and every vertex should be connected, ठीक है. Every vertex should be connected to all remaining vertex, ठीक है. So each and every vertex should be connected. Okay, let's check K5 again. That is shape of K5. Now you can see that this vertex, okay, A is connected with all the 4 vertex, ठीक है. A जो है बाकी चारों के साथ कनेक्टेड है. B है, that is also connect with all the 4 vertex. C है, that is also connect with all the 4 vertex, ठीक है. So सभी वर्टेक्स की डिग्री क्या है, that is equal to 4, ठीक है. So if it is a K5 then degree of all the vertex should be 4. If it is a K7 then degree of all the vertex should be 6, ठीक है. If it is a Kn then degree of all the vertex should be n minus 1. Clear? So this is our graph we have. Okay, these are the 5 vertex V1, V2, V3, V4, V5. It is a simple graph. Why it is a simple graph? क्योंकि इस ग्राफ में कोई भी लूप नहीं है. There is no any parallel edge between any two vertex. ठीक है, so it is simple and each and every vertex are connected to each other. Each and every vertex are connected to each other. Okay. So first we'll consider 5 vertex. ठीक है, named as a V1, V2, V3, V4, V5, and then after connect it. So this being the case, we must have a circuit, okay, going from V1 to V2, V2 to V3, V3 to V4, and V4 to V1, V5 to V1. That is a create one of the pentagon. Okay. Now place the 5 vertex to the plane. That is V1, V2, V3, V4, V5. Okay. Place the 5 vertex to the plane, and then after create one of the circuit. Okay, connecting this 5 vertex as a V1 to V2. Okay, this V1 to V2, V2 to V3, V3 to V4, V5, V5 to V1, and that look like one of the circuit. Okay, and now this graph is a pentagon. Okay, that create one of the pentagon we have. This is a pentagon with 5 sides, 5 vertex. Clear? See the first figure. That is our first graph, and this pentagon must divide the plane of the paper into the 2 regions. Okay, now observe this graph, and this will divide the plane into the 2 regions. Which 2 regions? One is inside the pentagon and second is outside the pentagon. Okay, one of the region that is inside the pentagon, that is inside region, and that is outside region. Okay, we can use both the region to connect all the edges. Clear? Up inside as well as outside, you can use both the region to connect all the remaining connections. Okay, all the boundary edge we have created. Okay, now which edge is remaining? all the inside edge remain. Okay, all the inside edge is remain. Clear? We have used the 5 edges, okay, to connect this all the vertex, and it create one of the cycle V1 to V1, okay, and that look like one of the pentagon. Clear? See this graph, that is a graph we have. We just develop the boundary area, okay, and at this stage we get a 2 region, one is inside and second is outside, and still all the 5 inside edges remain. उसको आपको कनेक्ट करना है टू रिमूव दिस क्रॉस, क्योंकि वहीं पे क्रॉस हो रहा है. देयर इज नो एनी क्रॉस एट एनी बाउंड्री. ठीक है, बाउंड्री पे कोई भी क्रॉस नहीं है. ऑल द क्रॉस इंटरसेक्शन आर अवेलेबल टू द इनसाइड सेट. ठीक है, तो उसको आपको रिक्रिएट करना है. ठीक है, रिकनेक्ट करना है सेम कनेक्शंस such that we can remove the crossover. So that is the first step. Clear? Is it clear? Consider 5 vertex, make one cycle V1 to V1, and it's one of the pentagon, and from this stage you will get the 2 region, one is inside and second is outside. Okay, now next step. In the next case, we'll now connect one more edge. Okay, we'll connect remaining connection. So which connections we consider it here? V1 to V3. Okay, V1 to V3, because V1 to V2 is connected now. Now which connection is remaining? V1 to V3. Okay, this connection let's connect. So since the vertex V1 is connected to V3 by an edge, this edge may be drawn inside as well as outside. Okay, so there are two possibilities to connect it. This and second is outside possibility to connect V1 and V3. Clear? There is another possibility to connect outside region. Connect by outside region. Okay, with same vertex. So V1 is to be connected to V3 by means of an edge, and this edge may be drawn inside or outside. Okay, inside or outside. कोई भी आप ले सकते हो. You will get the same answer at last. Inside or outside the pentagon, without intersecting the 5 edges, without intersecting the all boundary 5 edges, that drawn previously, means in the last step we consider the boundary. So there is no any intersecting with this edge, okay, of any of the boundary edge. Suppose that we choose to draw a line from V1 to V3 to inside the pentagon. So that I consider it here. Okay, you can also prefer this option. Okay, you can also consider this option to connect V1 and V3. You will get the same conclusion at last. Okay, you will get the same conclusion at last. Okay, so here suppose that I suppose here, let's connect V1 and V3 by inside the region. Okay, inside the pentagon, and see this second graph. Okay, that is a graph B. And if we choose outside, means this one, if we choose outside the region, we end up with the same conclusion. Okay, we end up with the same argument at last. Clear? That I connect V1 and V3 by inside. Okay, you can also use this on the second option. You will get the same answer at last. Clear? That is a step 2. Clear? Consider pentagon. Explain the pentagon. Clear? Which type of circuit will be followed and how many regions at the stage. That is step 1. In step 2, connect V1 and V3. So how many possibility you have to connect V1 and V3? So you have 2 possibility to connect the V1 and V3. One is the inside and second is outside. Explain it here. Okay, and then after consider which options you have preferred. Okay, so suppose that V1 and V3 are connected by the inside region. Okay, and we will also consider same conclusion for the second one. That is a step 2. Okay, still 4 edges is remaining. How many edges I have included now? 6 edges. Okay, still 4 edges remaining to connect. Clear? So let's connect it in the next step. Okay, so we use the previous graph, which I consider as the inside edge between V1 and V3. Okay, so now connect V2 and V5 and V2 and V4. Okay, V2 to V4 and V2 to V5. Clear? So now we have to draw. Now we have to draw an edge from V2 to V4, and another is V2 to V4, V2 to V5, V2 to V5, and V2 to V4. Okay. Since neither of this edge can be drawn inside the region, neither of this edge can be drawn inside the region. If we draw to the inside the region, it will be cross with the inside edge. Okay? If we connect the inside the shape, okay, inside the pentagon, it will be cross with this edge. यहाँ पे वो दोनों cross हो जाएगी. And we are applying the important process is that. So here you have to skip this point. Okay, skip this step here. So we cannot connect to the inside way. Okay. So what is the possibility now? There is only one possibility. Connect to the outside the region, outside the pentagon. Okay. So consider to the outside V2 to V5 and V2 to V4. Okay. If you use the second option here, then you can consider the inside form. Suppose कि यहाँ पे आपके पास second graph है, ठीक है, जहाँ पे आपने outside the pentagon connect किया, ठीक है. If you connect V1 and V3 by outside way, V1 and V3, now you can use the inside way to connect V2 to V5 and V2 to V4. ठीक है. If you use the second option, then you will get this choice in this step. ठीक है. अगर आपने second option use किया है, you will get this choice in this step. You cannot connect by the outside region. ठीक है. इसमें क्या होगा? You cannot connect V2 and V5 to the outside the region. It will be crossed with this edge. हमने यहाँ पे inside में लिया है, so now we have only one possibility to connect it, only outside the region. Okay, only outside the region. Okay, can be drawn out inside the pentagon without cross over the edge. Okay, it's already drawn, so we draw both the edges outside the pentagon and see this graph number 3. Okay, that is a step 3. Now still how many connection is remaining? How many edges we have used? That is a 5, 6, 7 and 8. Still 2 edges is remaining. Okay, अभी 2 edge connect करनी बाकी है. Which 2 edge? See, this is a degree 4. That is now fixed. Okay, we cannot connect any more edges from this vertex. इसकी degree fix हो गई, इसकी degree 4 हो गई. That is now complete. So V1, V3, V2, V4 and V5 all they have degree 3. Okay, and still V1 to V4 connection is remaining and V2 to V5 is remaining. Okay, because we know that each and every vertex should be connected to each other. Okay, so एक V3 and V5 connection है and V1 and V4 connection. These are the remaining here. So let's connect it in the next step. So let's connect V3 and V5. ठीक है, V3 V5 को पहले connect करते हैं. Then after we'll connect V1 and V4. So let's connect V3 and V5. That cannot be drawn outside the region. Okay, V3 V5 को अगर आप outside draw करोगे, so it will be cross with this outside edge. If we connect to the outside, it will be cross with this place. Okay, so we cannot connect to the outside the region. We have only one possibility to connect it, that is inside the region. Okay, अगर आपने second graph लिया है, then you have this possibility. If you consider this second graph, then you have this possibility. Okay, you can connect this from the outside way. You can connect now from the outside way, V3 and V5. If you consider this case here, but we consider this one, so here we cannot connect outside region. We can connect only the inside. Clear? So now V3 and V4 is complete. Okay, V3 has a degree 4, V2 has a degree 4, V5 has a degree 4. Still V1 has a degree 3 and V4 has a degree 3. So connection of this is remaining. ठीक है, V1 और V4 का connection remaining है. So if we connect to the inside, if we connect it to the inside, it will be cross with the inside edge. ठीक है, अगर आप उसको inside से connect करते हो, it will cross with this inside edge. ठीक है, वहां पे cross हो जाएगा. And if we connect it to the outside the region, उसको outside draw करते हो, connect करते हो, so it will cross with the outside edge. Okay, it with the outside edge. So what is the conclusion? Okay, since we have yet to draw the edge between V1 and V4, and the edge cannot be placed outside as well as inside. Okay, outside or inside the pentagon without crossover. Okay, and thus the graph cannot be embedded to the plane. Okay, thus the graph cannot be embedded, means embedding is not possible in the K5. Okay, embedding is not possible in the K5. Okay, and therefore the conclusion will be the complete graph with 5 vertex is a non-planar graph. Okay, that is the first theorem of this unit. Is it clear? Here you can also consider this graph. Okay, you will get this situation, and then after you just apply the last one. It is not possible in this graph also. Okay, this graph of letter, it is not possible to connect to the inside. It will be crossed with this edge, and it is not possible to the outside. It will be crossed with this edge. Okay, in the second case. So that is a minimum number of vertex. Okay, minimum number of vertex. That is a 5 vertex, and minimum number of edges. That is a 9 edges, which is a non-planar graph. Okay, in the minimum number of edges, so 10 edges, which is a non-planar graph. Clear? आपको सिर्फ K5 को तो इम्बेड की प्रोसेस आप अप्लाई करते हो उसको सिर्फ एक्सप्लेन करना है. ओके, बाकी कुछ इसमें है नहीं इन दिस थियरम. You check all the step again. We just explain the K5 graph only. K5 को ही आप एक्सप्लेन कर रहे हो. How we can draw the K5? ठीक है. First consider 5 vertex. ठीक है. Connect this all the 5 vertex, make one pentagon, and it create one of the circuit. Clear? V1 to V1, and from this stage you have the two region. One is inside and second is outside. Okay, that is a explanation of this part. And you can mention the definition of complete graph. It is not compulsory to mention it here, but that is for our reference. So what is meaning of complete graph? ठीक है. Definition वहाँ पे mention करनी compulsory नहीं. ठीक है. That is for our case, how we can define complete graph. Clear? So that is a proof of this part. Okay. And second में आपको एक connection use करना है. ठीक है. V1 to V3 का. Clear? So connect it by the inside as well as outside. Clear? We can connect use any region at that stage. If we use the inside region, that is given as per the graph. If you connect the outside, we will get the same conclusion at the last. Okay, we will get the same argument at the last. So explain it here. Okay, you have the two region to connect V1 and V3. One is inside and second is outside. And let's consider the inside region to connect V1 and V3. Clear? Then after draw this graph here. Okay, see this picture. Okay, see this graph, following graph. And if we consider the outside the region, we'll get the same conclusion at the last. Okay, that is explanation of second part. Second graph को आपको explain करना. ठीक है. Now third में, in this third one, we consider now some more connection. Okay, V2 to V4 and V2 to V5. So in this case, you have only one possibility to connect the V2 to V4 and V2 to V4. Okay, only outside region. If we connect it, okay, if you consider the inside region, it will be crossed with the inside edge. So it is not possible to connect by the inside graph. Okay, so connect to the outside region. Clear? Draw this graph here, and then after explain. That is step 3. Clear? Now in step 4, still two connections remaining. One is a V2 to V3 to V5 and V1 to V4. Consider any of one of them. Okay, we can also start with the V1 and V4 here. Okay, यहाँ पर V1 और V4 भी ले सकते हो, and then after you just prove it for V3 V5. Clear? So prove it. Okay, we have only inside way to connect the V2, V3 and V5. Okay, only inside way to connect V3 and V5. Explain it, and still one more connection is remaining there. That is a V1 and V4. So it is not possible to draw connect V1 and V4 without cross over the edge in this graph. Okay, it is not possible. Connect V1 and V4 without cross over the graph. Okay, so what does it mean? Embedding is not possible to the K5. Okay, so thus the graph cannot be embedded on the plane. Cannot be embedded means embedding is not possible to the graph. Okay, and therefore write your conclusion. You can also draw this graph here. Okay, that is mentioned by red line. Okay, this will be crossed with this edge. Okay, and therefore we skip this cross to say it is a planar graph. But here we cannot remove this cross. Okay, we cannot connect it. We cannot make a complete graph with 5 vertex without cross over the edge. Okay, and therefore the complete graph with 5 vertex is a non-planar graph. Is it okay? Is there any confusion? Any query, any doubt to anyone? So please ask. And it is very important theorem, okay? Because in this graph theory, hardly we have 7 to 8 theorem, okay? And unit number 4, we have 3 theorem, okay? 3 to 4 theorem. Unit 5, we have no any theorem, I think, okay? Unit 6, there is a, I think one more theorem will be there. 2 theorem are there, okay? 2 to 3 theorem. So hardly 6 to 7 theorem, okay? And this all are very important for offline exam, okay? If it is an online form, then there will be no any proof will be asked in the MCQ form. अगर offline होती है exam, then all the theorem are very important for 6 to 8 marks. It's also very important. Okay. Is there any confusion? Any query? This is for your task. There is a K33 set, okay, and I modified this set as the second one, okay. So now verify that they are isomorphic or not, okay. If they are isomorphic, clear, then we can consider the B design, okay, graph of B in place of the A. Why it is requirement of the B graph? Because just look the graph A, it has a more cross, okay, more intersection between the two edges comparison to the second one. Okay, in the second one we have only 3 cross between 3 edges, and here we have 5 to 6 intersection between the two edges. Clear? So comparison to this one, it is easy to prove that it is non-planar. क्लियर इसमें आपको सिर्फ 3 एज देखनी है यहाँ पे आपको काफी सारी एज मेंटेन करनी है ठीक है सो जस्ट चेक दैट they are isomorphic or not. If they are isomorphic, then we can use the second graph in place of the first one. Okay, now verify they are isomorphic or not. That we already discussed in the last lecture how we can verify the isomorphic graph. isomorphic graph. Okay, it's easy to verify. Okay, why it is required the isomorphic concept here? Because we'll verify this graph to planar or no. Okay, in place of the A. Okay, we'll use the second graph for verification of planar or not. Okay, why we consider second graph? Okay, why it is not first one? Clear? Because in this A, okay, that is both are the shape of K33. Okay, both have the 6 vertex. This has the 6 vertex also 9 edges. This also contains 9 edges. Clear? But they are isomorphic graphs, so we can use this one in place of the A. Okay, because the A contains the more crossover comparison to the second one. Okay, it has some more crossover between the edges comparison to the second one. Okay, in the second one there are only 3 cross. Only one cross between the 3 edges. Okay, that's only one. That is only one crossover between these 3 edges. Clear? So now it is easy to verify that. Okay, it will be the planar or no. Okay, we just focus only 3 edges. All the boundary 6 edges will be as it is that. Okay, we just modified, we just recreate these 3 edges such that can we connect the same adjacency relation. Okay, should be fixed without crossover or no. Clear? So here we have to prove it. Okay, employing the visual geometric representation, geometric argument, similar to those used in the proving the above theorem, means the previous one. Okay, K5 is a non-planar. It can be shown that the second graph of Kuratowskis, that is second graph of Kuratowskis, is also a non-planar graph. ठीक है, सेम आर्ग्यूमेंट. कौन सी आर्ग्यूमेंट हमने यूज की थी K5 के लिए? We first consider 6 vertex named as a V1, V2, V3, V4, V5, V6. ठीक है. Then after connect this 6 vertex, okay, you will get a first graph which involve one of the cycle V1 to V1. Okay, V1 to V2, V2 to V3, up to V5, V5 to V6, and V6 to V1. Okay, you will get a first graph. You will get here, proof is not given there, but that is very easy to prove it. You will get this first graph. ठीक है, इसको आपको एक्सप्लेन करना है जो हमने K5 में एक्सप्लेन किया था. कंसिडर 6 vertex, clear, and then after connect it all the 6 vertex by the 6 edges, that is V1, that is V2, V3, V4, V5, and V6. Clear? Explain it. That is a K33 graph with 6 vertex, and we create one of the cycle there, and now from this stage we have the 2 region. Okay, one is the inside, it can be defined into the 2 region. One is the inside and second is a outside. Okay, that we explain in the first step of the proving the K5. Okay, now in the second step, connect one edge. Okay, इन तीनों में से कोई भी एक आप ले सकते हो. ठीक है, and connect it and explain it. How many possibility you have to connect it. ठीक है, आपके पास कितनी possibility है to connect it. ठीक है, so at that stage you have the, फिर से ग्राफ बनाते हैं. ठीक है, proof is not given here, but it is also very important for the exam to prove that K33 is a non-planar. Okay, now let's connect V1 and V3. Okay, so how many possibility to connect V1 and V3? 2 possibility. One is inside जो हमने अभी किया है. ठीक है, and second is outside. आप outside region भी ले सकते हो to connect the V1 and V3. Clear? Still 2 edges remaining. 2 edges remaining है. So explain in the third step. ठीक है, okay, there are to connect the, consider this graph as it is here. Okay, this connection is as it is, clear, V1 and V3. And now let's connect this and this vertex. ठीक है, that is here V1 and V4. V1 और V4 को हम connect करते हैं. ठीक है, so we cannot connect to the inside. If we connect it to the inside, it will be crossed with the inside edge. So we have only one choice to connect V1 and V4. ठीक है, V1 and sorry, that is V1 and V4. यहाँ पे V6 है, sorry, that is V6 and V3. That is V6. So it is V1, that is a V2, V3, V4. and that is V5. Okay, so we cannot connect V1 and V4 to the inside. We have only one possibility to connect it as the outside edge. Okay, outside the region. Clear? So explain it. Okay. Now let's connect the V1 and V6. V1 and V4. So here V1 and V4 we cannot connect to the inside because the one of the edge is already drawn. If we connect it, it will be crossed with this edge. So there is only one possibility to connect the V1 and V4. That is only outside region. Okay. So let's connect by the outside region and then after draw this graph. Okay. It is clear up to this. Now still one more edge is remaining. Which edge? That is in between V2 to V5. Okay. In between V2 to V5. So if we connect it here, okay. In the last graph, you have to explain it. Consider the fourth graph. All the connection will be as it is here. Okay. And now let's connect. If to the inside edge, okay. And if we connect it to the outside, okay, outside sun connect karte hai, let's say, it will be crossed with the outside edge. Clear? So it is not possible in any way to connect it without crossover. Okay? So therefore the K33 cannot be embedded on the plane. Okay? Means embedding is not possible in K33 graph. And therefore the K33 is a non-planar graph. Is it clear? This part is not given in this slide. Okay? This is not given in the slide how we can prove it. But only two lines is mentioned here, employing the same argument that we used in the previous theorem. Okay? In the proof of previous theorem, use it here to prove the K33 is a non-planar or not. Okay? And that is the argument. You can use it there and you can explain it. Is it clear? Is there any confusion? Okay, so these are the two special graphs, K33 and K5, which is a non-planar graph. Now there are some properties are that, okay, for 1 mark short question and 1 mark MCQ part. Okay, we can consider MCQ from this one. Both graph are simple graph. Okay, दोनों graph simple है because they are complete graph, complete and complete bipartite graph. So we cannot include any loop and parallel edges that. So both are simple graph. Both are non-planar. ठीक है, दोनों non-planar है. There is no any planar case. Removal of one edge or one vertex that convert to the planar situation. Okay, अगर ग्राफ में से हम एक एज रिमूव कर देते दोनों में से, okay, दोनों में से एक एज डिलीट कर दो, so now the remaining situations we can easily maintain as a planar situation. Okay, just delete one of the edge from this graph, कोई भी edge. Okay, it is not fixed that आपको edge delete करनी. Just delete one of the edge from the graph, both the graph, and then after check the remaining condition. Okay, remaining graph. That graph you can easily embed to the planar graph. Okay, you can easily embed to the planar. Why it is you can easily embed that? Because in this proof of the K5, there is only one edge is that which is the create a problem. Okay, which is create a problem. This edge. If I delete this edge, now rest of the graph is a planar. Okay, if I delete this one, V1 to V4 की edge आप निकाल दो यहाँ से, delete कर दो. ठीक है, एक ही edge delete करनी है, इसको यहाँ से निकाल दो, तो remaining part you can easily embed as a planar form. ठीक है, and then after just delete one of the vertex. इसमें से कोई एक vertex निकाल दो, delete V5. Okay, delete V1, and then after observe the remaining part. Okay, delete V5. तो which shape you will get? K5 में से एक वर्टेक्स आप डिलीट करते हो तो कौन सा शेप बनेगा? K4. Yes, very good. Okay, if you delete one vertex from the K5, which shape you will get? K4. क्योंकि एक वर्टेक्स निकल गया, अब कितने बचे? 4 बचे. एक एज वर्टेक्स निकल गए तो उसके साथ 4 एज भी निकली ना. Okay, we delete also the 4 edges, and in K4 we have 4 vertex with 6 edges. Okay, 4 vertex with 6 edges, and delete one vertex from the K5. It has a 4 vertex with 6 edges only. Clear? So it is a K4, and K4 is easily embedded to the planar form. Okay, that is easily embedded to the planar form. Clear? That is for K5, and now for K33 also. Okay, delete one edges. ये जो ये है इसको यहाँ से निकाल दो, ठीक है, क्रॉस हो रही लास्ट वन निकाल दो. The remaining step is easily you can embed. Okay, rest of the graph is easily embedded. ठीक है, and also delete one vertex. एक vertex को आप निकाल दो, ठीक है, vertex को यहाँ से निकाल दो. The remaining step will be the K22 either or K31. Okay, K33 अगर आप है इसमें से एक निकाल दो तो remaining step is a K32. Okay, तो K32 को आप easily embed कर सकते हो, that you already checked. ठीक है, ये निकाल दो. The rest of the graph is a planar situation. Okay, so easily we can create. And now fourth one, it is important. Okay, the first graph in the non-planar graph with the smallest number of vertices, and the Kuratowskis second graph is the non-planar graph with smallest number of edges. Okay, smallest number of edges and smallest number of vertex. In this K5, we have 5 vertex and 10 edges. Okay, and in K33, there is a 6 vertex and 9 edges. Okay, these are the edge and these are the vertex. So now compare this both. In the first graph, K5 is the smallest, is a non-planar graph with the smallest number of vertex. Why the smallest number of vertex? You can, in the K33, how many vertex we have? 6 vertex. In K5, we have 5 vertex. So now compare the vertex form. Vertex को compare करो तो which will be the smallest one? 5. Okay, so K5 is include the smallest number of vertices, which is a non-plan. Okay, now compare the edge portion. Okay, in the K5 there are 10 edges. In K33 how many edges are there? 9 edges. So which will be the smallest? 9. Clear? So it is a non-planar graph. Second graph is a non-planar graph with the smallest number of edges. Clear? With the smallest number of edges. So we can consider any short questions, either any MCQ, that which of the following graph is a non-planar graph with smallest number of edges. First option is a K5, second is a K33, third is a K32, fourth is none of this. ठीक है, तो आपको पता होना चाहिए कि कौन सा ग्राफ कौन के लिए किस पार्ट के लिए सही है. ठीक है, कौन सा ग्राफ एज के लिए करेक्ट है, कौन सा ग्राफ वर्टेक्स के लिए करेक्ट है. ठीक है, which of the graph is a non-planar graph with smallest number of vertex. ठीक है, that is a K5. Which of the graph is a non-planar graph with smallest number of edges? That is a K33. Clear? That is verification. You can verify this what the case here. Okay. Now next is the exercise for you. That is limit minimum. It is not possible now. If you consider K6, okay, अगर मैं K6 ग्राफ लेता हूँ तो K5 is a subset of K6. ठीक है, K5 कैसे बनता है? K6 में से बनेगा ना. ठीक है, just remove some vertex and edges. एक वर्टेक्स निकाल दो तो K5 बन गया. ठीक है, K7 में से एक शॉट निकाल दो तो K6 बन गया. ठीक है, so K5 is a subset of K6. सबसेट ही नॉन प्लानर है तो उसका यूनिवर्सल सेट कैसा होगा? That is also non planar. ठीक है, K5 is a subset of K6 and we prove that K5 is a non planar. ठीक है, तो उसका जो यूनिवर्सल सेट होगा जिसमें से K5 आपने लिया है that also will be the non planar form. ठीक है, तो K6 after K5 जितने भी ग्राफ है it always a non planar graph. ठीक है, after K3 जितने भी ग्राफ है, ठीक है, which include the 10 edges, 11 edges, 13 edges, 14 edges and so on, that always a non planar form. You cannot embed this graph as a planar form. ठीक है, you cannot embed this graph as a planar form. Clear? Therefore, we required the junction here. What is purpose of the junction? To develop the electricity network. Okay. What is the purpose of that? We can remove this crossover. Okay, if you do K33 set, okay, with 3 main switch and with 3 fan only. Clear? 3 switch and 3 fan only. Clear? There is no any crossover there. Clear? Now we have the 9 fan, some tube light are there, okay, and some more switches. So how we can maintain this network? Clear? So we need some nearest point. At that point, we can remove the crossover. Okay, at that junctions we can develop new network there. Okay, and we can separate the wire also. Okay, in all the directions. Clear? That is a application of this one. That is easy one. Okay, and then after the embedding portions will start. Okay, just check it. Which of the graph is a non-planar graph? It's very easy. Okay, now all the simple example are there. Okay, what is answer of first one? Is it a planar? Urvisha, what is answer of first one? Urvisha, Devans, Jai, Arjun. Am I audible? Okay. So what is answer of first graph? Is it a planar? Yeah. Okay. You can see that no any intersection at any place. Take a first graph is this side. जो graph है ना वो. There is no any intersection. Okay. It is modified the graph and that is look like now planar. Okay. Directly modification is already given there. So it is a planar. Okay. So यहाँ का answer आएगा planar graph. Second one is also planar. Clear? There is no any cross at any place. यहाँ पे vertex है, ठीक है? There is one vertex. Here there is a K4. यहाँ से एक remove and then after recreate outside. And there is a K3. Yeah. Which graph is here? ये कौन सा graph है? K4. Okay. 4 vertex with 6 edges, and all the vertex of degree 4. So all are planar graph. Okay. All the graph are planar. Is it clear? Confusion? First, second, third. These are the planar. Okay. Below 2 graph and this first one. There is no any modification is required. Clear? All this situation is a planar. And this one is a K4 shape, just without crossover. So it is also a planar situation. Now here some special graph is given that K4 we already checked. Okay, there is no any need to verify the K4. Now try it for K23, K45, and also the Peterson graph. Just try it. Okay, all of you. And then after try to embed it. If it is possible to draw without cross over the edge, then it will be planar. If it is not possible to draw without cross over the edge, then it is a non-planar graph. Clear. So K4 is a planar, K23 is also planar. Okay, just very. And K43 is a not planar. Why it is not planar? Because in the K33 we have 6 vertex with 9 edges, and here in the K43 we have 7 vertex and 12 edges. Okay, so obviously it will be the non-planar. And is it possible? Is it possible to make this Peterson graph as a planar? You have to remove this star, okay? Because there is a cross at the star here, and just recreate the situation in such a way that is we can reconnect again all the vertex as it is without crossover. Okay, so just try it. It is also non-planar. Okay, just check it, verify that. Just draw the 2 to 3 possibility there, and then after find the conclusion that it is a non-planar. Okay. Is there any confusion to anyone? Yeah. Any doubt? Any queries? Okay. Now try it this way. Apply the embedding procedure and make this graph as a plan. Just try it. It is planar. Okay. Just draw this graph. Okay. Answer is a planar, but आपको उसको planar में convert करना है. That is important here. ठीक है? Planar and non-planar is not important, but how we can make to the planar, that is important. ठीक है? Just try it. What is your answer? Is it planar or not? Devans, Nirav, Bhavik, Dipsa, Madhav. Have you check it? Urvisa, Smith, Subham, Sivangi. Just check it again. It is a planar. That is one of the solution. Okay, you can find another graph in place of that also. Okay, you can find another graph in place of that also. What is a problematic vertex in this graph? Okay, there is one of the answer here. If we check the B, okay, B is adjacent with AED. So just stretch this B to the inside the graph, okay, inside the graph. So now this 3 8, okay, ये दोनों को यहाँ से निकाल दो, ठीक है. And stretch this vertex to the inside the graph. इसको यहाँ पे inside पे ले लो. ये जो तीनों एज है, ठीक है, ये इन तीनों के साथ क्रॉस हो रही है. So it will be now without cross, ठीक है. So consider this part to here, okay, that is now B. It is connected with A, B, E, clear. Rest of the connection as it is, and then after consider C connection, and that connect to the outside the boundary. Just recreate it such a way that. And you can see this graph. If I connect A and B and C, if I connect B and C, which graph? If I connect B and C, B और C को मैं अगर connect करता हूँ H से, तो which type of graph? This is K5, and as we know that if I delete one H from the K5, it you already checked. Okay, if I delete one edge, otherwise one vertex from the K5, the rest of the situations will be the planar situation. Okay, rest of the situation will be the planar. If I delete one edge, एक ही एज को अगर मैं डिलीट करता हूँ K5 में से, okay, so this graph will be the planar situation. यही K5 ग्राफ है with deletion of one edge. ठीक है, B और C जब डिलीट हुआ edge notation, rest of the are connected. Clear? B और C को connect कर दो तो all the vertex have degree 4 now. 5 vertex with all the vertex have degree 4, so it is a K5. Now there is no one edge, okay, comparison to the 10 edge. There is 9 edge now, so we can easily embed this graph to the plan. Okay, that is possible to make the planar situation. Now try to draw another graph in place of that and make it to the planar. Okay, इस ग्राफ के आपको दूसरा ग्राफ फाइंड करना है for the same situation. Okay, just think about that. Consider first 5 vertex and start to the connecting. Okay, consider 5 vertex and start to the connecting such a way that no two any edge should be intersected any place. Clear? Now that we already checked. Okay, that is a K4 and that is a K33. Now try it for this one. Make this graph to the planar. Sir, is there any? No, there is no any some specific result we have. How many planar graph you can draw? Okay. Is there no any fixed formula for the given graph? How many planar graph you can create? Okay, just consider this both graph, both are planar graph, and you just verify it. Okay, we'll discuss it in the next lecture. Okay, we'll revise both the graph in the next lecture. Okay, answer is both are planar, but your task is you have to recreate this graph such a way that cannot to any edge or intersect. Okay, just okay. Here we'll keep up to this.